All right, so we've talked about sine and cosine as trig functions. Now we're going to talk about the last four: tangent, secant, cosecant, and cotangent. Okay, so let's just so we've already talked about this. If we have an angle T, right, this is in standard position. Here's the initial side and the terminal side. Here's our x, y values where that would intersect with the unit circle. This has radius 1, right? And we've already talked about this x would be the cosine, and the y value is the sine of this angle T, okay? Well, here's the definition of the last four trig functions, okay? Tangent T is y over x. Obviously, x can't be 0. Cosecant is 1 over y. Secant is 1 over x, and cotangent is x over y, okay? And either x or y can't be 0. So it's either just reciprocals of x and y or ratios of x and y, right? And also notice the abbreviations that we use. So tan is short for tangent, but we just write TAN. Cosecant, CSC, is short for cosecant. SEC is short for secant, and COT is short for cotangent. Okay, so those are the abbreviations that we use. All right, so what if we had this angle here, T, and the x and y values where that intersects with the unit circle are negative square root of 3 over 2, 1/2. Find all the other trig functions, okay? We'll find all the trig functions, actually. So just looking at this, hopefully we can remember this value is going to be our cosine, and this value here is going to be our sine. Right, we can just read those right off. Now we're going to use the ratio of these x and y values to find the other four trig functions. So tangent, remember, is y over x. So here's our y value, here's our x value, and we just do the algebra. Right, remember to divide by this. Look carefully at this. We invert and multiply. The 2's cancel. We get negative 1 over square root of 3. And remember, we don't like radicals in the denominator, so we can rationalize that, multiply by square root of 3 over square root of 3 to get this form, negative square root of 3 over 3. Secant is 1 over x, so 1 over the x value, invert. Since it's in the denominator, we get this. We rationalize the denominator to get negative 2 square root of 3 over 3. Cosecant is 1 over y, so 1 over 1/2 is just 2. And cotangent, x over y, again, we have this ratio. We invert and multiply, the 2's cancel, and we just get negative square root of 3. Okay? So nothing too fancy going on here, right? We just have our x and y values. We can read the sine and cosines off of those, and then we can use these different ratios to calculate our other four trig functions. All right, so what if they don't give us a drawing and they don't tell us the x and y values, they just tell us the measure of t is pi 6. All right, so we're going to have to think back to the last section to calculate what our x and y values would be, right? If t is pi 6, let's think that's in quadrant 1, right? And that's a 30, 60, 90 triangle. The y value is going to be 1/2 because that's going to be across from the 30 degrees. The x value, or the cosine, is square root of 3 over 2. And it makes sense that they're both positive, right? If we think about where pi 6 is on the unit circle, it's in quadrant 1. Okay, so now we have, this is our x value, and this is our y value. So now we just say, okay, tangent is our y value over our x value. Plug those in, rationalize the denominator. Secant is 1 over the x value, right, by definition. The x value of cosine is square root of 3 over 2. And multiply, rationalize the denominator to get that. Cosecant is 1 over the y value. 1 over 1/2 is 2. Cotangent of pi 6 is going to be the x over y. Put in the ratio, we get square root of 3. So you hopefully are noticing that the sine and cosine values are fundamental to everything that we're doing. Everything else we can express in terms of sine and cosine, right? Also, maybe you're noticing like these square root of 3 over 2 are popping up a lot. Square root of 3. Yeah, at first they seem a little bit random at the beginning of the semester in trig class, but by the end you're going to be very familiar. Okay, these angles, these reference angles, pi 6 and things like that, we're going to use them over and over and over. Okay. In fact, here's a table, and we will talk in class. You're not going to have to fill out this entire table, but you are going to have to fill out a table that for the first three, sine, cosine, and tangent. Okay. And let's just look at this table real quick. Let's just look at maybe across this cosine row. Let's look for patterns. Maybe pause this and look across the sine row, just those two, and look for patterns. So let's see, it looks like we could write this if we wanted to as square root of 4 over 2 or square root of 1 over 2. So it's square root of 4 over 2, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, square root of 0 over 2. And how about the other way? This is the exact same numbers, just in the opposite order, right? This matches that, 1/2. These are the same. Those match, those match. There's some patterns here, okay? This looks like a lot to remember. It's not too bad. Tangent, we can always, for all these other 4 rows, we could always figure them out by ratios, right? All right, we'll talk about that more in class. Okay, so let's think about using reference angles, okay? So in this quadrant, this is listing the trig functions that are positive in this quadrant. Okay, they are all positive in quadrant 1, right? And in each of the others, 2 are positive, right? So there's a bunch of ways we can think about this. One is that we could use the acronym a smart trig class. Isn't that nice? That's you guys. In this quadrant, all of the trig functions are positive. Smart, in quadrant 2, sine and cosecant, which is 1 over sine, are positive. In quadrant 3, trig, a smart trig, tangent is positive, and it's inverse. Class, C, is in quadrant 4, cosine, and it's inverse. Okay, so a smart trig class can help us remember which quadrant each of these trig functions is positive in, right? So sine is positive in quadrants 1 and 2. Cosine is in 1 and 4. Tangent is in 1 and 3. And then they're inverses. Okay? All right, so we're going to use this when we're talking about reference angles. It says use reference angles to find all 6 trig functions of negative 5 pi 6. All right, so I want you to think for a minute, and I want you to make a little sketch. Where is this angle? Negative 5 pi 6. Well, it's a little bit less than pi. It's negative. So going back here, it is going to be about right here, right? It is in quadrant 3. So what's going to be positive? Tangent and cotangent are going to be positive. Everything else is going to be negative. All right, so we're going to have to use a reference angle. So let's go back here. Negative 5 pi 6 is about right here. What's the reference angle for it? Well, it's pi 6 away from the x-axis. So the reference angle is pi 6. So what's cosine of pi 6? Think about that for a minute. Cosine of pi 6 is square root of 3 over 2, right? You could always go back to this table if you weren't sure. Square root of 3 over 2. And in quadrant 3, cosine is negative. We could also think of it, the x value is going to be negative. So it's negative square root of 3 over 2. Sine of negative 5 pi over 6. It's 1/2. And in quadrant 3, sine is negative. We could also think that the y value on that circle is negative. So sine is negative 1/2. Now it's just ratios. Tangent is going to be the y over x. Do the math. We get square root of 3 over 2. Tangent, remember, is one of the two trig functions that's positive there. But even if we didn't remember that, once we take this ratio, that it all washes out, right? These negative signs cancel each other anyway. So if we just know sine and cosine and get those right, everything else we can get right. All right, secant, cosecant, cotangent is, we do the ratios. Okay, it's 1 over this. Secant, so secant is 1 over x, so 1 over this, and then rationalize the denominator. Cosecant is 1 over y, so do what's 1 over negative 1/2. And cotangent is 1 over this. When you rationalize the denominator, you just are left with square root of 3. Okay. All right, so let's talk about even and odd functions. That's just a review. If we had, looks like a quadratic here, this is even. Why? What does even mean? It means if we folded things along the y-axis, they match up. This is odd, right? X cubed is odd. What does that mean? It has origin symmetry. We could rotate about the origin and it would match up, or we could fold it twice and it would match up, right? So this is even, this is odd. So let's think about which trig functions are going to be even and odd. If we have a t, an angle t, and an angle negative t, which are going to be the same? Well, the x value is the same, right? Which is cosine. Cosine of t equals cosine of negative t. So remember, this is the definition of even. Let's think about sine. Well, the y value, sine of y, or sine of t, this y value, here's negative y, right? So sine of t, negative t equals negative t. So this is odd. Okay. I invite you to pause the video and think about this for a minute, okay? I want this to make sense to you. Look at this chart and think about why some are going to be even, some are going to be odd. In a few weeks, when we look at the graphs of sine and cosine and tangent and all these trig functions, you were going to come back to this idea of them being even or odd, but this is where it comes from, okay? So here's a nice summary of it. Cosine and secant are even, and all the rest are odd, okay? So how could you use this easily? If the secant of angle t is 2, what is the secant of negative 2? Well, also going to be 2.